Alright, welcome to my first video. I'm going to be explaining general inverse derivatives. So, starting off, we have the main three: tan inverse, sine inverse, and cosine inverse. We can see that sine inverse and cosine inverse are just a difference of a negative for the cosine. So, let's get straight into applying some of these. So, let's say the derivative of tan inverse of 2x. So this equals 1 over 1 plus the function of x squared, so 4x squared. And since there's a 2 inside of the function, we need to use chain rule and multiply by 2, giving us an answer of 2 over 1 plus 4x squared. Let's do another. Let's do derivative of cosine inverse of ln of x. So this equals 1 over, let's put the negative on the top, of the square root of 1 minus the function squared, which is ln of x squared. You can't just put the squared on the x since ln is a function. And we use chain rule again, multiply by the derivative of ln of x. Now, we can simplify this to get negative 1 over x root 1 minus ln of x squared. Let's do one more example for the general derivatives. d dx of sine inverse of, let's do e to the x plus 3. So when we take the derivative, I'll put it down here, we get 1 over the square root of 1 minus the function squared, and I'll just distribute it out, e to the 2x plus 6 e to the x plus 9 times the derivative. So we can simplify this to get e to the x over the square root of 10 minus e to the 2x plus 6 times e to the x. So for the next three inverse derivatives, we can see cotangent of x is just a negative derivative of tangent of x. And secant and cosecant are the most complex ones. You have 1 over the absolute value of x times x squared minus 1, not 1 minus x squared. So let's do an example of this. d dx of cosecant of 4x. So this equals 1 over the absolute value of 4x, which is just going to be 4x here, of 4x squared overall, so 16x squared minus 1 times the derivative. And this simplifies to 1 over x times square root of 16x squared minus 1. Alright. And that's your final answer. Let's do one more. Let's do the derivative of cotangent inverse of secant inverse of x. You could use trig here to solve it, but we're going to use calculus. So we have 1 over the square root of 1 plus the function squared. So that would be secant inverse x squared multiplied by the derivative of the inner function. So now we need to do 1 over absolute value x times the square root of simply x in this case, x squared minus 1. Here's a challenge question. Pause and see if you can do it. Alright, so let's work through the challenge question. The derivative of tan inverse x cosecant inverse x. So we know that we have to do product rule here. So tan inverse x times the derivative of cosecant inverse x, which is negative 1 over absolute value x square root x squared minus 1 plus cosecant inverse x times the derivative of tan inverse x, which will just be 1 over 1 plus x squared. And let's see if you can simplify this. I just multiply it out to get negative tan inverse x over absolute value x square root x squared minus 1 plus cosecant inverse x over 1 plus x squared. That's your answer. That's it for inverse trig derivatives. I hope you learned something new and that was helpful.